this video, I wanted to talk about function algebra. Actually, this week in class, we talked about this a little bit, but I wanted to do a few more examples, specifically with polynomial functions. Now that we've gone through division, we can talk about every single combination of these functions, basically any sort of arithmetic. So let's just say f of x is the polynomial x squared minus 2x plus 7, and g of x is x minus 5. First question it asks us is, what is f plus g, f minus g, f g, and f divided by g? And in class, I talked about these three, but I didn't really talk about f divided by g. But of course, what that would mean is just take the entire f function and divide by the entire g function. And so let's write them all out. And basically, with polynomials, we can always calculate and simplify those results, which is kind of the goal of looking at this. So f plus g, we could write that as f plus g of x. That would be the entire f function as this is defined, plus the entire g function. So this would be x squared minus 2x plus 7 plus x minus 5. And since adding polynomials is just a matter of combining like terms, we could do that. So in the first polynomial, we had x squared, and there were no like terms in the second. Then we had negative 2x plus x, which would be negative x, and 7 plus negative 5, which would be plus 2. And when we're combining functions together, in this case adding them, we get a new function. That's kind of the main idea of the algebra of functions, is when I add one polynomial to another, they combine and they form a new polynomial, which would have different properties based on that combination. And for subtraction, remember that we need to be careful, because if we're subtracting the first function, f minus g, we want to make sure that we're using parentheses, or we can't forget about the distributive property. Because if I want to take this whole function and subtract this whole function, when you're subtracting a polynomial, obviously all the terms must be subtracted, or we need to apply distributive property, because that would give me I would need to distribute the negative out of, well, minus x and plus 5, really. And we could rewrite it all out, but I prefer to just do it in my head. X squared will not combine with either of those, but negative 2x minus x will be minus 3x. And this would be plus 7, and this would really be plus 5. Plus 7 plus 5 would be plus 12. And notice the difference between those two is different, because both of these parts change signs and add. And that's exactly like what I said with dividing polynomials. You want to change all the signs, then add, because that's what you do when you subtract polynomial functions. And just as a reminder, we refer to this as a sum function, this as a difference function. The product function is when you're going to multiply them, and the quotient function is simply one function divided by the other. So if we were trying to find the product function of fg, that would just be the first times the second. And again, I'm using parentheses, notice, when I'm doing this, because when we have multiple terms, we have to use our rules of algebra. If we're taking an entire function times another entire function, those parentheses are necessary around both functions in order to get the full product of those. Since here we have 3 terms times 2 terms, we need to fully FOIL this, and that would leave me with a total of 6 terms. Remember that you can count the number of terms, 3 and 2, within your polynomial to figure out how many full products you would have. But I would do x squared times x is x cubed. X squared times negative 5 is negative 5x. Then negative 2x times x is negative 2x squared. Then negative 2x times negative 5 would be plus 10x. Then 7 times x, 7x. And 7 times negative 5 is negative 35. And of course, when foiling or distributing, really those mean the same thing. When completely multiplying all of those terms to all of those terms, we get a total of 6 things, and we can combine like terms. And it looks like in the second one I forgot the x squared, which just looking back at, I noticed an error, because x squared times negative 5, of course, should be x squared. But we can simplify the result by combining like terms. which would leave us with negative 7x squared and plus 17x. And that would be our product function. And notice that when you're adding and subtracting functions, the degree of those does not change to the max degree of your original polynomial. But when we're multiplying, the degree actually gets larger because obviously we're taking an x squared and we're multiplying it into an x, which produces a polynomial function with degree 3. Now for the quotient function, which is just f divided by g of x, or f over g, whichever you want to say, this would just, of course, be the first function divided by the second. So we could actually write this in either way. We could write this as x squared minus 2x plus 7 divided by x minus 5, like that, or you could write it using kind of in the way we did in the last section when we're talking about polynomial division. But in this case, you could leave the function in this form, which we refer to as a rational function, and we're going to talk more about how you can just study these functions in this form as is, but you still could divide these using either long division or synthetic division. In this case, let's just go ahead and divide it, but technically that's not something that's necessary because this question doesn't say to simplify or to get the answer. But naturally, it can be nice to actually do the math and figure out what happens. And even though I didn't say it, that's usually implied. So if I was going to divide those to f, I could use synthetic division here, which would be 1, negative 2, and 7. And I'm dividing by x minus 5, so I change the sign. And then finishing my division, I'm always going to drop, multiply, add, multiply, add. So what I'm going to get is x plus 3 plus 22 over x minus 5. And that would be another way I could write f over g, totally equal to writing it just as a division without actually calculating the result. X plus 3 plus 22 over x minus 5. And there we have it. In the next video, we'll talk about evaluating using these, evaluating the functions at specific values, stuff like domain, and eventually what composition means and what's the difference between that and these other combinations.